Welcome back, everyone. We're still doing exponents, but we're going to talk about scientific notation, which uses exponents in it. So, our objectives are that you'll be able to convert between standard notation and scientific notation. You'll also be able to multiply and divide expressions involving scientific notation. That will happen in day 2. We're doing lesson 8 day 1 right now. You'll also be able to state the rule for scientific notation. So let's go over the definition of scientific notation. A number in scientific notation is written as a product between of a number between 1 and 10, and not including 10, and a power of 10. So if you remember, this is what it looks like. Here we have a number, and this number is in between 1 and 10, and we have a multiplication sign. So that makes it a product, and we have 10 raised to a power, so 10 with an exponent. This is the scientific representation of. So we have 315,000. That's what this really represents. It really represents 315,000. So let's see if we can spot this. Is each number below written in scientific notation? So remember, in order to be in scientific notation, it has to be a number between 1 and 10, a time sign, a 10, and an exponent. So let's see. We have a 10 with an exponent. We have a multiplication sign, but this number is not between 1 and 10. So this would be no. Let's try this one. Well, right away I see that this is 13.2, so this is another no. It has to be between 1 and 10. Let's check our last one. 3.25, that's good. A multiplication sign, a 10, and an exponent. The exponent is negative, and you know what? That's okay. That's okay. So, this one is yes. It is between 1 and 10, and we have all the other components. So this is in scientific notation, and later on I'll show you what it equals. This page here is mostly for notes. We have a really big number, and this is one of the reasons scientific notation is used, because people don't want to keep writing these big numbers. So we have this big number, and they change it into scientific notation. So 1.54 multiplied to 10 to the 11th power is really this number. So the first number, 1.54, that's called the coefficient, and the coefficient must be greater than, or it could equal 1, and it has to be less than 10. Then we have a multiplication, and we have 10, that's the base, and our exponent is 11 in this example. Okay, this is going to walk us through how do you put this number here into scientific notation. I like this approach that they do. You take the number and immediately put a decimal right here so that you have only one digit to the left of the decimal. That way your number will be between 1 and 10. The next step is basically count how far you have to go to the right in order to be at the end of the number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we end at 11. So because it took us 11 moves to go to the right, that will be our exponent. I used to teach it the other way, where you go to the left. I love this way much better. Put the decimal right here. That way you always know that the decimal goes right in the spot, so that there's only one number to the left of it. Okay, we took this number and made it into scientific notation. Here we have two examples on this page that we're going to take these numbers, which we call are in standard form, and we're going to put them into scientific notation. So let's do step 1. So take the number and always put the decimal so that it's as far left as you can go with one number to the left of it. So we're going to put it right here so that we only have one number to the left of it. Now, step 2, we're going to count our decimal places that it takes to get to here. Well, it took 11 decimal places to get there. So my third step is to write my new number. So 1.95, then I drop the zeros off. Do not write the zeros at the end. Multiplied to 10, and then I'm going to take this 11 and put it right there. Done. That's it. That's scientific notation. Just remember, this always has to be between 1 and 10. Let's do this one as one more example. Here we go. Take that decimal, put it right here. Okay, now we've made a number which is 6.75. Step 2, we're ready for step 2. Step 2, we're going to count and walk our way to the end. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. Took me 8 spots. So my new number will be 6.75 multiplied to 10 to the 8th. So same number, I shouldn't have said new number. It's the same number, I just wrote it in a different way. So they're the same number. On this slide, we have a couple examples that we just did, and all we have to do is move the decimal and fill in our blanks. And then we have a couple examples working backwards. So we want to practice going from standard note or scientific back to standard notation. So go ahead, do this with me. Follow the steps. Put your decimal here and count. 1, 2, 3, 4, 5, 6. So that we know this will be 6 and this will be 1.83. Perfect. Feel free to pause and do it yourself. Alright, next one. Let's put our decimal right there, and then we're going to go backwards. 1, 2, 3, 4, 5. So we moved 5 spots. So 5 spots. And our number was 3.57. Going the other direction. So here's my advice. Take your number, 7.89, and write it over here without the decimal. Now what we need to do is follow this instruction. It says 10 to the 7th. It is positive, so positive exponents make the number bigger. So this number is going to get bigger, and we're going to go to the right. So I always start here because that's where this decimal is, and I'm going to move 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. So I need to add 5 zeros to my number, and now I'm done. So my number was 78,900,000. So my final answer is right there. Okay, let's try one more. So we have 9.235 times 10 to the 9th. So I'm going to take this and write it right here. 9.235. Then I'm going to walk 9 spots to the right starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9. In all those empty spots we're putting zeros, so I should have 6 of them. 1, 2, 3, 4, 5, 6 zeros. There's my answer right there. Commas are good. Every 3 numbers place commas, and there's my new number. Well, same number, just written in a different way. Okay, probably should have had more practice on smaller numbers, so pay really good attention. We'll do this one. We know how to do this one already, so let's write this in scientific notation. Do it with me. Put your decimal here, okay, and then count. 1, 2, 3, 4, 5, 6, 7, 8. So our new number is 2.34 multiplied to 10 to the 8th power. Okay, so take really good notes on this because I don't have a lot of examples on this. If the number is less than 1, so it's a decimal, it's a small decimal, follow the same steps. We're going to take our decimal and put it right here, okay? And we're going to count how far it takes to go this way. Because we're going this way and because this number is small, we will have a negative exponent. So just remember that. Here we go. 1, 2, 3, 4, 5. So my new number is 6.3 multiplied to 10 to the negative 5. Okay, to the negative 5. The negative means that the number is very small and it's less than 1. Okay? I don't like to say left or right because that can confuse kids, so I try not to say that. Well, let's do these two. Elephant's mass is 8.8 times 10 to the 4th. So we're going to write 8, and instead of where the point is, I'm going to put my pencil or pen and go 1, 2, 3, 4. So I moved 4 spots because of that exponent. I'm going to add zeros. My final answer will be 88,000 kilograms. That's a pretty heavy elephant. Okay, one more. Ant's mass. So the mass of an ant is going to be really minute, very small, and that this negative tells us that it's going to be a small decimal. So same thing, we're going to write 7, 3, but the negative tells us to go that way to make it small. So I'm going to move 5 to the left. Here we go, 5. 1, 2, 3, 4, 5. I'll put zeros here. Here's my final answer, 0.0000073, and that's my answer. Okay, practice problems. So, place these into scientific notation. Follow the steps. On these practice problems, just like the examples, fill in the blanks. So in this case, you're going to write the number and what the exponent is. This time you're going to take it and put it back into standard notation. And then we have a couple examples just like the last slide. So bring any questions you have next time we meet, and take care.